Imagine a world, or rather, no world at all, without the vast expanse that separates everything. Without space, the very fabric of our reality, our understanding of existence, would unravel into an unfathomable singularity. It's a concept so fundamental, so omnipresent, that we rarely stop to consider its absolute necessity. Our universe, as we perceive it, is defined by dimensions: length, width, depth, and time. These dimensions are intrinsically linked to the concept of space. Without three-dimensional space, there would be no extension, no direction, no here or there for anything to occupy. From the smallest subatomic particle to the grandest galaxy cluster, everything occupies a certain volume of space. This occupancy is what gives objects their physical presence and allows them to interact, to move, and to exist separate from one another. Consider the Big Bang Theory, our prevailing cosmological model. It describes the universe originating from an extremely hot, dense singularity, which then expanded. This expansion is the creation and stretching of space itself, not just matter moving into pre-existing space. If there were no space, this initial singularity would have nowhere to expand into. The concept of an expansion would be meaningless, as there would be no outwards to go. The very beginning of our universe, as we understand it, would be impossible. The fundamental forces of nature, gravity, electromagnetism, and the strong and weak nuclear forces, all operate across space. They dictate interactions between particles and objects, allowing stars to form, chemical reactions to occur, and life to emerge. Gravity, for instance, warps the fabric of spacetime. Without space, there would be no fabric to warp, no distance over which gravity's influence could extend. Planets wouldn't orbit stars, and galaxies wouldn't coalesce. Think about light. Light travels through space as electromagnetic waves. These waves require a medium or space to propagate. Without it, light itself couldn't travel, plunging the universe into eternal darkness. The concept of a speed of light would be nonsensical. There would be no distance to cover, no time interval to measure its passage. Information, as we know it, couldn't be transmitted across any expanse. Even our perception of time is intertwined with space. Einstein's theory of relativity demonstrated that time and space are not separate entities, but form a single continuum called spacetime. Events unfold within this framework. Without space, there would be no relative motion. Think of two objects. Their positions are defined by their distance from each other in space. If there's no distance, there's no distinct location, and thus no movement from one location to another. This means no planetary orbits, no tectonic plate shifts, no wind blowing, no water flowing. The universe would be utterly static, a frozen, unmoving tableau of potential existence that could never actualize. Chemistry, the very basis of matter, depends on atoms forming molecules. This process requires atoms to be separate entities, with electrons orbiting nuclei in defined regions of space. Without space, all matter would collapse. Imagine all protons, neutrons, and electrons simultaneously occupying the exact same point. The repulsive forces between like-charged particles, like protons, would be infinite, leading to an immediate, catastrophic theoretical breakdown. In a universe without space, the very concept of separation is lost. There is no distinction between one thing and another, because everything would occupy the exact same point of existence, indistinguishable from everything else. This lack of separation extends beyond physical objects. It would apply to concepts, ideas, and even consciousness. How could one thought be distinct from another if there's no space to differentiate them? Life, as we know it, is fundamentally spatial. Organisms have internal structures, cells, organs, all arranged in specific ways. These require space within the body to function independently, yet cooperatively. Photosynthesis, respiration, digestion. All biological processes involve molecules moving, reacting, and changing positions within a spatial framework. Without it, the chemical reactions necessary for life simply couldn't occur. The diversity of life across Earth, from microscopic bacteria to gigantic blue whales, is a testament to the myriad ways life has adapted to and exploited different spatial niches. Consider the human experience. Our senses, sight, touch, hearing, all rely on spatial information. We see objects at a distance, feel the texture of something distinct from us, and hear sounds propagating from a source. Without space, vision would be impossible, as there would be no distance for light to travel from an object to our eyes. Hearing, dependent on sound waves propagating through a medium, would also cease to exist. Navigation, geography, mapping, these are all concepts built on the premise of space. We define locations, measure distances, and chart courses across physical landscapes. Without space, these disciplines are meaningless. Architecture, engineering, and urban planning are entirely dependent on space. Buildings occupy volume. Structures are designed to span distances, and cities are laid out with spatial relationships in mind. Humans have always explored, whether it's across continents or into the cosmos. Exploration itself is the act of traversing space, discovering what lies beyond the familiar. Without space, there's nowhere to explore. Art and culture also reflect our spatial reality. Sculptures occupy space, paintings create spatial illusions, and dance involves movement through a defined area. Even music uses the spatial arrangement of notes and silences. Our very language is riddled with spatial metaphors, over and above, deep insights, far-reaching consequences. These expressions derive their meaning from our fundamental understanding of space. The concept of a quantum foam, proposed in quantum gravity theories, suggests that at incredibly tiny scales, space-time itself might not be smooth, but rather a turbulent, fluctuating foam. Yet, even this foam exists within a larger spatial context. The potential existence of parallel universes is another mind-bending concept that relies on space. These other universes are imagined to exist alongside ours, implying a spatial separation even if we can't perceive it. Even seemingly abstract concepts like data and information, in their physical manifestation, occupy space. Server farms are vast physical structures. The internet relies on a global network of cables and satellites existing in space. The void of interstellar and intergalactic space isn't truly empty. It's permeated by sparse matter, cosmic background radiation, and dark matter and energy, all contributing to the universe's spatial characteristics. Black holes, those enigmatic cosmic entities, are regions where gravity is so intense that nothing, not even light, can escape. Their defining characteristic is an event horizon, a boundary in space beyond which return is impossible. If there were no space, the concept of a black hole's singularity would be the only reality. Everything would be that singularity, without the surrounding spatial fabric that defines the black hole itself. The universe is still expanding today, a phenomenon first observed by Edwin Hubble. This ongoing expansion means that the amount of space between galaxies is continually increasing, pushing them further apart. This expansion isn't galaxies moving through space, but space itself stretching, carrying the galaxies along with it. It's like dots on an inflating balloon. The dots themselves aren't moving on the surface. The surface itself is growing. Without space, the idea of stretching or growing would be meaningless. There would be no medium to expand, no increased separation to observe. The fundamental dynamism of our universe would vanish. The cosmological principle states that on large scales, the universe is homogeneous and isotropic, meaning it looks roughly the same everywhere and in every direction. This homogeneity is a spatial property. Our measurements of cosmic distances, critical for understanding the universe's size and age, rely entirely on the existence of space. Light years, parsecs, these are units of spatial distance. The discovery of cosmic microwave background radiation, the echo of the Big Bang, revealed a nearly uniform temperature across the observable universe. This uniformity implies that all parts of the early universe were once in causal contact, connected by space. The concept of dimensions beyond our familiar three spatial dimensions is explored in theories like string theory. These extra dimensions are often theorized to be compactified or curled up, but they still represent a form of space. If there were truly no space, then the idea of compactified dimensions would be self-contradictory. There would be no compact anything, no dimension to curl up within. The existence of dark matter and dark energy, though invisible, is inferred through their gravitational effects on visible matter and the universe's expansion. These effects are observed across space. Without space, there would be no gravitational influence to observe, no expansion to accelerate. The cosmic dance between these mysterious components would be utterly absent. The universe's ultimate fate, whether it continues to expand indefinitely, collapses in a big crunch, or tears itself apart in a big rip, all depend on the properties of space and spacetime. Each of these scenarios fundamentally relies on space either expanding, contracting, or being stretched to breaking point. Without space, there are no such possibilities. Even philosophical considerations of nothingness often implicitly rely on space. Is nothingness an empty void, or the absence of even a void? The latter is closer to a universe without space. This thought experiment isn't just abstract. It underscores how deeply ingrained the concept of space is in our conceptual framework of existence. It's not just a backdrop. It is a fundamental component. Without space, our very definition of an object becomes impossible. An object is something that occupies a distinct region in space. Remove space, and the distinction vanishes. Our notion of dimension itself is predicated on space. Length, width, and height are measurements of spatial extent. If there's no space, there are no dimensions to measure. The idea of causality, that one event leads to another, also relies on events being distinct in space and time. If everything occupies the same point, then all causality collapses into instantaneous coexistence. In such a scenario, quantum mechanics, with its probabilistic nature and particle-wave duality, couldn't exist. There would be no wave function to describe a particle's probability of being here or there. Even the act of thinking, the firing of neurons in our brain, involves signals traveling across tiny spatial gaps called synapses. Without space, these intricate biological networks couldn't function. This hypothetical absence of space leads to a universe of absolute uniformity and non-differentiation, a state where everything is every other thing because there's no spatial boundary to distinguish them. It's a universe where concepts like empty or full have no meaning, because there's no volume to be either. It transcends our spatial vocabulary entirely. The very act of asking, what if there was no space, implies a spatial framework for understanding the question and its implications. Our minds are built to process spatial information. Without space, the entire universe, with its billions of galaxies, stars, and planets, would fold into an infinitely dense, dimensionless point, a point that is everywhere and nowhere simultaneously. Such a state would be beyond human comprehension, defying all physical laws and intuitions. It's the ultimate non-existence from a spatial perspective. Our universe is a spatially rich and dynamic place, allowing for complexity, diversity, and evolution. It permits the vast distances between celestial bodies, the intricate structures of living organisms, and the very concept of discovery. We exist because of space. Our sun is distinct from Earth, our cells have boundaries, and our thoughts are individual. All these rely on the fundamental truth that things can be separate and occupy different regions. Embracing the concept of space, rather than questioning its existence, allows us to marvel at the sheer scale and beauty of the cosmos and the intricate dance of matter and energy within it. So, the next time you look up at the night sky, or simply observe an object across a room, remember the indispensable role of space, the silent canvas upon which the entire drama of existence unfolds.